Today we're going to be looking at something called the unit circle and investigating how we can use that to help us solve problems with trigonometry. But before we do that, yesterday you were introduced to a new way of measuring angles called radians. And briefly, I just want you to get familiar with using radians on your calculator. The scientific calculators that you've probably been using deal with angles in degrees. So if you get your scientific calculator and if you look at the display screen, you're probably going to see the word degree, D-E-G, or on some calculators you'll see a square with a capital D inside the square, and that's how you can tell that your calculator's in degree mode. And in degree mode we can do things like evaluate the sine of 45. Okay, you've been doing that for 3 years at least. You type in on your calculator either the sine button and then 45 and then hit equals, and you'll get your answer. Or, depending on your calculator, you'll type in 45 and then the sine button and then equals to get your answer. Okay. What we want to figure out is how to work with a radian measure of an angle on your graphing or on your calculator, your scientific calculator. So first of all, you need to try and figure out how to convert your calculator to radian mode. Some calculators have a button. That's the mode button. My calculator has a button labeled DRG, and if I press that once, it gives me some options to change to radians or degrees. Okay, I would spend some time looking and trying to get your calculator in radian mode. You know you're going to be in radian mode if your calculator displays rad or a square box with a capital R in it. And with your calculator in radian mode, we can now do things like evaluate the sine of pi over 4. Okay, pi over 4, if I multiply by 180 over pi to convert to degrees, is equivalent to 45 degrees. So with your calculator in radian mode, press sine of pi divided by 4 and then hit equals, or vice versa, pi divided by 4 and then the sine button. And you should find that the sine of 45 degrees is equal to the sine of pi over 4 when your calculator is in radian mode. And with your calculator in radian mode, we can evaluate the cosine of pi over 4, and you should get 0.707, and the tangent of pi over 4, you should get it exactly equal to 1. If you're having trouble with your calculator converting it to radian mode, don't worry, I can help you in class tomorrow. Just make a note of that so we can take a look at your calculator. What we really want to do today is talk about something called the unit circle. The unit circle is a circle on top of the XY axis with its center at the point 0, 0 and a radius of 1. So I've drawn one, a unit circle here, my XY axis, my center's at 0, 0, my radius, R, is equal to 1. And then based on what you did last year, we've learned how to define angles in standard position based on their angle of rotation away from the positive x-axis. So I'm rotating this terminal arm an angle of theta, and I get a point xy somewhere on the circle. And we can use trigonometry to figure out what the value of that point is. We also need to remember our special triangles from grade 11. So we need to remember our special triangles from grade 11, and there were two that you learned. One of the special triangles was a triangle that had two 45-degree angles, and it had side lengths in the ratio 1, 1, and root 2. So that's the 1, 1, root 2, or the 45, 45, 90 triangle. The other special triangle that you learned in grade 11 had a 60-degree angle, 30-degree angle, and it had sides in the ratio 1, root 3, and 2. The 1, 2, root 3 triangle, or the 30, 60, 90 triangle. So we're going to use these two triangles to help us solve some problems with the unit circle. So I gave you in class a copy of a blank unit circle with some values that you can fill in. If we look at the first quadrant, okay, and if we remember the cast rule, all of the ratios in the first quadrant are positive. So moving around the first quadrant, starting with an angle of 0 degrees, and thinking about the special triangles, my next angle would be 30 degrees, and then 45 degrees, 60 degrees, up to 90 degrees. If I'm on a unit circle and I haven't rotated at all my terminal arm, and I'm sitting at 0 degrees, my point on the unit circle would be an x value of 1 and a y value of 0. I'm 1 unit over on the x-axis and I haven't moved up at all. So I can imagine with my 30-degree angle dropping a line from that point down to the x-axis and making a right angle. So now that we've dropped this line and created this right angle triangle, we have a triangle whose hypotenuse is 1, and we need to solve for the length of either two sides. So if we think about our special triangles, and in this case we're thinking about a 30, 60, 90 triangle. I have sides that look like this. If I want to find the value of x using this triangle, I'm going to find the cosine of angle theta, and that's going to be equal to my adjacent side x divided by my hypotenuse, which is 1. So this quickly becomes the cosine of angle 30 is equal to x. And we know from our special triangle that the cosine of 30 degrees is equal to root 3 over 2. And what that means for us is that the value of the x-coordinate of this point on the unit circle, where the terminal arm is 30 degrees, is root 3 over 2. To find my value for y, I'll do the same thing. Now I'm using my opposite side and my hypotenuse, which is 1. So here the sine of 30 degrees is equal to y. And the sine of 30 degrees is exactly 1/2. So my y value, this point on the terminal arm on the unit circle, is 1/2. While we're looking at the 30, 60, 90 triangle, I'm going to do the same thing with my 60-degree angle. So I'll drop an imaginary line down to the x-axis, create that right angle triangle with a hypotenuse of 1. If I want to find my length of side x and my length of side y, well, I can use my 30, 60, 90 triangle. X would be my adjacent side. In this case, I'm looking at the side adjacent to angle 60. So the adjacent side is 1. The hypotenuse is 2. So the cosine of 60 degrees is exactly equal to 1/2. To find the side y, I'm going to do the sine of 60 degrees. The sine of 60 degrees is the opposite side, √3, divided by the hypotenuse, which is 2. Notice how, for the 30-degree triangle and the 60-degree triangle, the coordinates switch. Last, I need to look at my 45-degree angle. Again, drop that imaginary right angle down to the x-axis. In our 45, 45, 90 triangle, we have sides of 1 and a hypotenuse of √2. So to find sides x and y, we can do it the same way. The x value is the cosine of 45 degrees. Cosine of 45 degrees is 1 over √2. However, we don't like answers where there's a root in the denominator. So in grade 11 you learned how to fix that. You can multiply top and bottom by √2 over √2. So the cosine of 45 degrees is exactly √2 over 2. We can find the sine of 45 degrees to find the y value. And looking at our special triangle, the sine of 45 is 1 over √2. Again, we need to rationalize. So the sine of 45 degrees is √2 over 2. And one last point in the first quadrant, our 90-degree angle. Well, if this is a unit circle with a radius of 1, then when we're on the y-axis, our x-coordinate is 0 and our y-coordinate is 1. You should convert all these angles into radians. 90 degrees is pi over 2 radians. 60 degrees is pi over 3 radians. 30 degrees is pi over 6 radians. And 45 degrees is pi over 4 radians. So that's our first quadrant. Let's take a look at our second quadrant. So again, thinking about the cast rule, the only ratio that is positive in the second quadrant is a sine ratio, which means cosine and tangent are negative. So continuing on with our rotations, if we start at 90 degrees, we keep rotating to find our special angles. Our next special angle is going to be 120 degrees. 135, and then 150, followed by our straight line of 180 degrees. And at this coordinate, our x value would be -1, and our y value will be 0. Converting this to radians, 180 degrees is pi. And then we have 3 pi over 4 is equivalent to 135. 5 pi over 6 is equivalent to 150. And 2 pi over 3 is equivalent to 120. So again, thinking about our special triangles. If I have a 30, 60, 90 triangle, normally in grade 11 we liked angles in standard position. So we looked at angles as a rotation from the positive x-axis. But sine and cosine aren't really defined for those larger values, those obtuse values. So when we're working with these triangles in the second quadrant, we need to think about as if we're rotating backwards off the negative x-axis. So there I have my 30-degree right-angle triangle. So there's our x and y sides. So here, if I'm trying to find x, finding the cosine of 30 degrees, cosine of 30 degrees, root 3 over 2, but this x value is negative. And since cosine is negative, in the second quadrant, I need to make sure I make that value, root 3 over 2, negative. The sine of 30 degrees is 1/2. Sine is a positive value in the second quadrant. Okay, looking at my 60-degree angle. To find the x value, the 60-degree angle, I'm going to do the cosine of 60. Cosine of 60 is 1/2, but it's negative. The sine of 60, root 3 over 2. And it's positive because I'm in the second quadrant, and my y values are positive in the second quadrant. And then finishing off with my 45-degree angle. My x value for the 45-degree angle is negative root 2 over 2. My y value is root 2 over 2. So you should have now filled in the first 2 quadrants of your unit circle. Okay, your homework tonight, after you're done watching this video, is to look for patterns in the first 2 quadrants and use those patterns to fill in the remainder of the information in quadrant 3 and quadrant 4. Okay, we're going to start class tomorrow by taking up these unit circles, by looking at the values, by talking about some of the other patterns that you can see, and then we're going to do some more applications involving trigonometry and radians. Okay, if you are having problems working on this unit circle tonight, you're welcome to Google the unit circle, and you'll find, I'm sure, many, many different solutions to any problems you have, or you're also welcome to email me if you need some help. Okay, thank you. Have a good night.